Welcome to homework.
So the question we try to answer now is, where do you weigh less, on a mountaintop or on ground level? So for this, I made a little sketch. Imagine this is the Earth. So this is the radius, r, and then we have an object which is sitting here and an object which is sitting here. And let's call this distance the mountain. So if we take a look at our equation, the force which is acting is a constant times mass 1 times mass 2 divided by the distance squared. So in our first case on ground, this equation is very easy. The masses are the same, g is the same. So we have our force which is acting, which is simply g m1 times m2 divided by the radius r squared. On the mountain, we can make now the assumption basically all the weight basically of the Earth, which is acting on the weight, is centered around the core. This is the base assumption for the theory. So the masses are the same, the constants are the same. So everything that changes is that we have the height of the mountain, dm, which is adding to the radius of the Earth. So here we have d plus r squared. And so if we now, let's call this actually FGM, and this FG little g. So if we imagine now, this force here becomes by a factor of d greater, smaller than this one, because d is a positive number and it gets squared. So we know that FGM is smaller than FGG. So with knowing this relation, we know basically when we are standing on the mountaintop, since our mass doesn't change, if we step on a weight, what will happen? We have a lower force pulling on our body and pulling on the scale. So the answer is basically, since our force is less, it will seem that on the mountaintop, it seems that our weight decreases.